Question 6 on page 18 asks us to write linear functions to satisfy the following conditions. And in part 1, we've been told that when y equals 3, x equals 2, and the rate of change is 0.5. So the linear functions I'm going to be writing are in the form y equals mx plus b, where m is my slope and b is my y-intercept. So starting out with part 1, we can see that we've been told the rate of change is 0.5. And another way of saying rate of change is the slope. So this is telling us that the slope of the line is 0.5. So plugging that in, we get y equals 0.5 times x plus b. So to figure out what b is, all we need to do is plug in a set of values for x and y. And we've been told in the problem that we have a point when x equals 2, y equals 3. So we can just plug these values in and solve for b. So this gives me 3 equals 0.5 times 2 plus b. And 0.5 times 2 is just 1. And subtracting 1 on both sides of my equation gives me 2 equals b. So the full equation for this linear function is y equals 0.5 times x plus 2. So in part 2, the information we've been given is that when y equals 3, x equals negative 3, and when y equals 5, x equals 3. So this corresponds to the points negative 3, 3, and 3, 5. So the first thing we want to do is figure out our slope m. And another way of writing the slope is the change in y over the change in x between 2 points. So this can be rewritten as y2 minus y1 over x2 minus x1. And looking at these points given, I'm just going to assign this first one as x1, y1, and x2, y2 for this other point. It actually doesn't matter which one you assign as which, as long as you plug them in to this formula for m in the correct way, you will get the right answer for your slope. So plugging these values in, we get 5 minus 3 over 3 minus negative 3. So evaluating this out, 5 minus 3 is 2 on the top, and 3 minus negative 3 is 3 plus 3, so that's 6 on the bottom. And simplifying this down just gives me 1 over 3, or 1/3. So now I'm going to plug in what I know into my general equation, y equals mx plus b. So this gives me y equals 1/3 times x plus b. And just like we did in the last problem to find b, we simply plugged in one point that we know is on our line. We're going to do the same thing here, and I'm just going to pick this first point to plug in. So this gives me 3 equals 1/3 times negative 3 for my x plus b. So 1/3 times negative 3 is negative 1, because my 3's cancel out. I just have that negative there. And then adding 1 to both sides of my equation gives me 4 is equal to b. So this means that my full equation is y equals 1/3 x plus 4 for part 2. In part 3, we've been told the graph passes through the point -2, 3 and is parallel to the straight line y equals -x. So the key bit of information to recognize here is that when lines are parallel, this means that they have the same slope. So in our line y equals -x, our slope, or m, is -1, because the coefficient on x here is a -1. So this means that m, our slope for the line that we're interested in, is also -1. So the information we have so far for the equation for our line is y equals -x plus b. And so to figure out b, just like we did in parts 1 and 2, we're going to plug in a point into this equation. And so the point we've been given is x equals -2, y equals 3. So I'm going to plug in 3 for y and a -2 for x. And you have to remember that the negative on here is due to the slope, so we have to make sure we keep our -2 for x as a separate thing. So when we evaluate this out, these negatives cancel. This just gives me 3 equals 2 plus b. And subtracting 2 on both sides of the equation gives me 1 equals b. So this means that my full equation is y equals -x plus 1, and that's the equation for the line in part 3.